Hi there, this is Ryan Chatterson, and today we are going to talk about hydroponic growing apparatuses. And we're going to talk about the types, the pros, and the cons. Okay, so just a quick introduction here on what we're going to cover throughout the lesson today. This presentation will cover a variety of methods currently being used in aquaponics. And this includes how each method works, the pros and the cons of each method, the varieties of plants that will work best for that method, so what's best suited for growing in that type of method. And then most importantly here to note, you can use most components that are designed for use in hydroponics so long as proper filtration is given to the water prior to being delivered to the plants, and that you follow a cleaning regimen for the specific equipment that you're using. So what does that mean? That means we need to process the water first before it goes through the hydroponic equipment. Don't count on that piece of hydroponic equipment as your biofilter, as a solids removal device, as a mineralization tank. Only count on it as a vessel to grow the plants. When you look at it that way, we can use anything that's out on the market as long as we prepare that nutrient solution first before delivering it. And again, why we bring that up, in an open water trough, it might not be, as big of a deal. We know we get nitrification, we get different things happening. But through a small aeroponic spray nozzle, something like that, that's extremely tight, spaced and can get fouled up with biofouling from bacteria growth, fecal matter, total suspended solids left in the water, any of that, well, that could be a problem if we don't treat it right first. Okay, so first we're going to talk about the raft method, my favorite here, okay? Deep water culture, DWC, that's what we have up there. So the method and how it works, hopefully by now we kind of have an idea how this works, but again, a raft is floated on top of a water trough that is fed by the effluent from a fish tank. So this can be recirculating, as we've talked about, or this can be in a decoupled fashion. Holes are drilled at an appropriate spacing in that raft for the plants that you select. Plants are placed in the raft for grow out, and then water quality and adequate oxygen levels are maintained. Okay, pretty straightforward. The pros of this type of growing method are, one, ease of harvest. Okay, so if we're going to harvest and let's say we're growing leafy greens on a schedule, something like a lettuce or say basil that we're going to trim, and we could even replant it or just take it out of the system. Well, a raft is basically a frictionless conveyor. So we can start at one end, harvest the raft, pull it out of the system, or just harvest in place and then remove the board, then go down to the far end and push, and all of the rafts will come to your one end. Easy. So you could push 100 feet full of 1,000 pounds of vegetables and it will move very easily across the top of the water. Okay, so that's one of the pros. It's very easy to use gravity to feed the troughs. So it's easy to integrate this into a recirculating aquaponic system. If we're going to, say like my system, like University of Virgin Islands, like many others that stage by gravity down through filtration and through the beds, then back to a sump, well, they really lend to that well. It's easy to incorporate that in that type of design instead of something that's, say, shoulder high, where it's going to maybe be higher than the fish tanks and we're not going to be able to use gravity to flow into that vessel. The troughs are very easy to construct. Okay, you can see how easy mine were to construct, and again, I can by myself put in a nearly 100-foot trough in one day. So I know you guys can, especially if you get a few helpers out there. If you do it in cement block, as long as it's leveled properly, very easy to do that as well. Generally, this requires a water pump with low pressure, low head pressure, okay, because we're using gravity to flow through it. And to flow through the filtration, we don't need a high pressure pump anywhere in the system. Okay, so that leads to low pressure, which can save us money on electricity. Saves us a lot of money on electricity. Most research available to date, primarily from the University of Virgin Islands. Okay, that's number one there. A lot of people, again, I'll mention many times, kind of write off University of Virgin Island as old data, old material, we need to move on. Well, and that's great if you actually understand what's going on in that system. But 95% of the people don't really know what's going on. They're not comfortable. They haven't grown using that configuration, but they're quick to write it off. So I would say, again, look back to the 30 years of research that answers a lot of these questions that we have. You don't have to go wondering because they've done it for us. So great, great, great place to start if you're getting into aquaponics. Okay, cons. More aeration needed compared to, say, Dutch buckets or an NFT system or other methods that utilize passive aeration. So any type of hydroponic growing apparatus that doesn't need aeration because of the type of the apparatus, whether it's an aeroponic vessel, whether it is, again, an NFT, something like that, well, they're made to not need additional aeration. So in that type of system, you're going to save a little bit of money and efficiency by not needing a blower to, or oxygenator to maintain oxygen levels in a water column. Some root crops, such as carrots and potatoes, will not form correctly without the hydraulic pressure provided by a media like sand or perlite. Okay, and that makes sense. If you grow a carrot in a raft system, some people will grow them and you get a little carrot, 2 inches that big. Well, that's about the depth of the neck cup. But you're not going to get a long carrot in this type of system. They grow like a long shoestring because there's no pressure forcing against that to cause it to bulk up, which it would naturally get growing in the ground. All right, so potatoes would be the same way, other tuber crops. But for the most part, those aren't high dollar crops in the first place. So if you're doing this as a business, you're probably not growing those anyways. It takes longer to build up nutrient levels because of the massive volume of water. That's just a product of the nature of the design. We have a lot of water in that as a reservoir underneath those plants in that trough. Because of that, it takes some time for nutrients to start to build up to adequate levels for the plants. Now, you can solve that two ways. You can go ahead and cycle the system and get the water adequate before you add plants in there, or you can try to increase feed and feed your maximum rate when you start out just to increase nutrients quickly and get this thing jump started. Again, out here at our farm, I had good plants growing within 4 to 6 weeks. So, there was not a 6-month startup or something like that, which you may hear other places. But there's more water, so it takes a little bit more time to build up. If we have an NFT system and, a recirculating aquaculture system, say we're transferring water to a sump for that NFT system, it's going to be much smaller than the total water volume of a large deep water culture raft system. Okay, so it happens a little quicker. And here's a nice picture. Again, here's some nice nasturtiums. Got some cucumbers up front, some more mature tomatoes in the back of those plants. And again, they're all floating on top of the water right there. You can see in the very bottom the white color of the raft showing through, and in the background here, going down another trough that runs behind that. Deep water culture, okay? This is Bright Farms, which is a hydroponic venture, but this is what we're talking about, okay? They've just utilized the space very efficiently in these greenhouses to grow greens. And you can see all underneath these is water, and they're movable, so they can move them from one end to the other. Well, how do we harvest in the middle of here? Well, they don't. They push them, and the entire crop is harvested from one end of the greenhouse. So varieties that work best. For the raft method, definitely lettuce and leafy greens. They work great. They really enjoy having their roots bathed in that water and even their upper root system in a cooler stream of water. And if you see temperature to temperature, if you have the same water temperature in an NFT system, as you do in a deep water culture system, but we raise the air temperature to say 95 degrees, plants are going to perform much better in a deep water culture system than they will in an NFT system because they have more of the root mass chilled and held at temperature. Okay, so it works really good with lettuce and leafy greens, herbs, squash, tomatoes, cucumbers, peas, okra, eggplant, peppers. I mean, we've grown over 500 varieties of plants, so that just goes to show you a little something about what can be grown. For me, now it comes down to what's going to be the most profitable for me to grow, because that's what we're doing. We're doing this as a business. But if you're doing this for home food production, you can grow just about anything you can think of. And I love weird varieties of vegetables. That's one of my things. That just makes it fun to grow vegetables as long as you can sell them for what you need to. But in my younger days, we grew a ton of different varieties in the weirdest colors and shapes you can imagine, just because we could. We could grow anything we could see or find seeds from, and did not have a problem in deep water culture. So I love this method. Anybody beginning, anybody doing this professionally, that's my recommendation right off the bat, unless you have a specialized circumstance that leads us to one of the other types of hydroponic apparatuses. Okay, so there are many more varieties that will thrive in a raft system. I just tried to mention there to you. Some root crops will grow in a raft, okay, like radishes, turnips, beets, onions, maybe not a 2-foot long Dagon radish, but your normal little small Easter egg radishes, something like that, they have no problem growing in there. Basically any type of root crop that you see actually kind of forms out of the ground a little bit, pops out, has a little bit of the head showing, they seem to grow just fine in aquaponics, in a raft system. One more thing I'm going to mention about the raft system here, okay, is risk. Now we talk about all of these different types of methods, but this is probably the least risky method that we're going to talk about. And that's because we have this large volume of water, of nutrient-rich water, which, again, one of the cons, it took us a little bit to build up that bank of nutrients. Well, one of the pros is it takes a while for that to go down. So I know Dr. Jim Ricosi told me that at the University of Virgin Islands, they had a hurricane come through one year. It blew down a lot of their equipment. I'm not sure what it did to the tanks, but basically they couldn't run the fish tanks for several weeks, and the plants kept growing for 3 weeks without a problem until they could get everything repaired. Well, if you have some type of disaster happen, which this is farming and there's a lot of risks out there, there's a lot of natural things that can happen, unfortunately. So just keep that in the back of your mind. I live in, Hurricane Central in Florida. We haven't had a good one in a few years, but if something like that happens, it's nice to know that you have that bank of nutrients, that if worst case scenario were to happen, you can still provide what you need for those plants you're growing and keep money flowing into the business. Okay, we'll move on now. We'll talk about some of the backyarder favorites out here. Ebb and flow system, which is also a flood and drain system. That's the name for it. Okay, so method and how it works. Water periodically floods and drains a tank filled with media throughout the day. Very easy to understand, okay? Tank full of media could be pebbles, little clay pebbles, it could be pea pebbles, it could be lava rock, it could be your choice of media. It just has to be something heavy enough that it's not going to float out of the tank when the system floods, and it has to be something that's not going to degrade or hurt your fish. So I've used perlite in flood and drain systems, and you'll get a layer on the top that is, you get algae because perlite wicks so well, but if you cover that with a little bit of panda film, which is a white film, and you actually poke out your spots for your plants, perlite works wonderful, grows great root crops in a flood and drain system. Okay, so we can use a lot of different types of media. The flooding provides nutrients to the root system, while the drain period allows a large amount of oxygen to come into contact with the roots. So that's the whole idea behind this, is that we have maybe 8 8% or 8 parts per thousand oxygen in the water, you know, at saturation, depending on temperature. In the air, we have close to 20. So when that drops, the roots are in contact with a much higher concentration of oxygen. Now, there are a few, that's always been the main selling point of ebb and flow system, okay? But there's a few things to wonder here. Since we don't see any increased growth rates by supersaturating the water with oxygen in a raft system, so bringing it above 8 parts per thousand, then that would tell us that even though this is getting in contact with above 8 part per thousand, it's coming into contact with 20, that's not really doing it any good, any better than, say, if it was submerged in water. Okay, so that's just something to throw out there to think about, but I'm not gonna stick my finger in everybody that uses flood and drain systems' eye, okay? Flood periods can be anywhere from once every 6 hours to once every 5 minutes, depending on the environment, media, and crop. Okay, so what does this mean? This means that we need to flood and irrigate a flood and drain table depending on how fast the water evaporates out and is used up by the plants. Okay, so what theoretically we want to do is we want to flood it, come back and check that table, stick your finger down an inch into the media or move it out of the way so that you can see, and check and see if it's still damp. Okay, I would check it at a half an hour, at an hour, at an hour and a half, and keep going until you actually see that media is drying out. And do this in the hottest time of the day, okay? Brightest sun, hottest time of the day. That will allow you to set your flood and drain cycle because you basically want to flood it before that media dries out. So if an inch in, it finally dries out after, say, 2 hours, but you still have moisture under that level, that's when we want to go ahead and trigger another flood cycle. So you want it to dry out a little bit, but not enough that you're going to fry any of that lower root system, okay? That's a real easy way if you set up a flood and drain system to get it going right off the bat. Flood periods, again, we just talked about that. Now, why would you flood once every 5 minutes? Doesn't make any sense, but this is just the other end of the spectrum. You're not gonna hurt the plants because you're still providing high oxygen water. Some people have even used these continuously flooded, and because they've got high oxygen water, the gravel is basically just holding whatever the roots, the roots in place. It's not really pulling in oxygen, doing all those other things we've talked about. Okay, a timer can be used to irrigate the bed and to set a timing interval, and that's what I would suggest to use. A repeat cycle timer is what it's actually called, and you can set the on time and the off time. So we can tell it that we want this to flood for 5 minutes, and we can tell it that we want that to happen every 3 hours. And it will do that for you. I think the timer is about $100, but it will work for years and years and years, and allows you to really dial in the flood cycle down from seconds up to minutes, but not like a timer you'd get for a Christmas tree or at the for a light when you go away that just has the little clips. You can use those, but usually they have something like a half-hour period or a longer interval, and you might not need to flood the bed for that amount of time. So more expensive timer is going to get you more exact dialing in and precise dialing in of that flood period, but it might not be necessary, and the $10 hardware store timer could probably work for you as well. I've used both. I've probably been where every one of you has been. I started out and wasn't huge. I started out in the backyard growing for myself, so I've used all the little cheap tricks to get here too. But I'm just trying to lay it all out there for you so that you know it's available. All right, a bell siphon is also commonly seen and used, and this is a mechanical means of flooding and draining a bed with the use of a siphon. All right, and I'm not going to go into detail on how to build a bell siphon, but what this basically does is it allows, when the water reaches a certain point, it starts a siphon. The siphon siphons the bed out, and then once it gets to a low point, it sucks in air, which breaks the siphon. Then the whole cycle repeats. It floods again, siphons, breaks the siphon. What this doesn't do is allow you to set an exact flood period, and something like that you're doing it every 20 minutes, 30 minutes, hour, where we could be stretching it out to maybe every 4 hours or longer. And what does that do? Save us money on a pump. So if our pump is only running for a few minutes every 4 hours, that's not going to hardly even, make a tick on the electricity bill. It's not going to be huge. It's not like you're running it 12 hours a day. You're going to be running it a total of maybe 30 minutes a day. So saves you power, makes your whole system more efficient. But the bell siphon is really cool, and if you're in the classroom or if you've got kids at home and you want to demonstrate some of these properties, by all means, build one with them, build one with your students, show them how it works, because it's cool, I'm not gonna lie. Okay, here's a few crops and some, again, I told you, backyard stuff. Here's some old backyard systems of mine from I don't even know how long ago. These beds are only 4 inches deep of gravel, okay? So I grew appropriate vegetables. These are some small 4-inch carrots. They formed beautifully and correctly in the pea gravel, not so much in lava rock and bigger aggregate. They also do great in perlite, like I mentioned. Here is Easter egg radish, and you can see it's purple. We buy these, they come in purple, yellow, red, white, a whole variety of colors. Very popular and attractive. And I'll tell you, if you're selling stuff, radishes are not a high dollar item. You may have seen them at the grocery store where you get a lot of them for a very low price. But if you offer something different, like multiple color varieties of radishes, and stick them in with a package with some other specialty products that you're growing, you can fetch a high dollar for them. So I've grown these where we sell 10 radishes for $5. They're multiple color radishes, and we sell it in a stew mix. I'm sorry, it was 10 radishes for $3. My apologies. But we sold that in a stew mix, and people loved it, and we would sell out of them every week. Go to the store, it's a lot more money for those. And a radish is a quick crop. I want to say 20 days from the time you drop the seed in to the time we're pulling it out of the ground. Extremely quick crop. Aphids like them, so they are a little bit of an attractant, but again, you can grow them. Here is some broccoli, okay? 4 inches of gravel there. Huge broccoli heads. Those broccoli heads were probably 8 inches, I think I remember, 8 to 10 inches when we harvested them. So I gave them enough room, of course, but only 4 inches of gravel. I would go with a deeper bed if you're going to actually build one. I like 12 inches. I think that's a great depth. But this just goes to show you you can grow in shallow beds as well. So let's talk about some of the pros here. Well, we have the ability to grow a wide variety of vegetables, such as root crops and long-term crops like fruiting trees and vines. Now, for most of us, that's not going to make any sense to grow a fruiting tree, a long-term fruiting tree in, say, a controlled environment structure, unless it's really high-dollar crop, because it takes up too much space. It's just going to give you a crop one part of the year and sit there the rest of the year. So it's probably not going to make a lot of sense, but for a backyarder, hobbyist, doing it for your own food production, something like that, by all means. And bananas grow great. Pawpaws grow great, but papayas also grow great. Pineapple, a lot of different stuff, but I guess pineapple's not a fruiting tree. But the point is, you can do it. Again, we can grow just about anything here. We've got the right concentration of nutrients in the water. It's just what's going to make sense. All right. We have the ability to incorporate worms into the aquaponics system, so earthworms, which will consume and break down organic material and provide a slow, steady stream of micronutrients, which supplement the nutrients provided by the dissolved fish waste. Okay. So let me kind of lay this out here like this. A lot of gravel and media systems don't remove all the solids. A lot of the solids are left and captured within this system. Okay, that's what the worms are going to digest. They'll also digest some leftover plant matter, but they're going to digest that and consume it, release it in the form of worm castings, and then the worm castings have to break down. Okay, so while this seems great, and it's nice again for a natural ecosystem, If we remove the solids and mineralize the solids, there's no reason to have worms in there other than to consume some old root matter, something like that. But we would rather remove that waste and get rid of it, dissolve it outside of the system, then add it in and give it back to the plants. That is what is preferential, because honestly, worms are not magic. They're not adding anything to what they're consuming, okay? They're not adding like, oh, you get magical, twice the nitrogen when it comes out the other end. That's not how it works. They're extracting, though in small amounts, they're extracting some nutrients from that matter, and then it's coming out the other end. And it has to break down because worm castings are not readily dissolvable in water. So let's just put that into perspective. They're great if you're using a flood and drain system and you have a lot of leftover root matter. I'd put some in there so that they consume them and break them down. But do not look at earthworms as a matter to control your solid waste from your fish tank. Because on a small scale that might work okay, but when we're trying to dial in and engineer these systems, there's a lot of unknowns that come into play by doing something like this. Again, a lot of unknowns by letting the waste break down in the gravel bed instead of in a mineralization tank. Or not really unknowns, but other variables that we need to account for. Okay, so some of the cons here, well, the weight. That media can be heavy. Rock, it's going to weigh a lot. It can be difficult to wash when you get it right off the truck. Difficult to support, depending on the weight and the type of media used. So you have to build some type of structure to hold this stuff. And most people that build media beds build them a little higher so that they're at waist level, easy to work in. Well, that's fine, but for all fruiting crops, you don't want them at waist level. You want to get them as low as possible so that you have a lot of vertical area to work with, vertical room to work with to grow and harvest these crops. So not ideal to start fruiting crops at waist level. You want to start those low. And again, if you think thousands and thousands of pounds of rock, it can weigh more than water, it can be difficult to support. So you need to just make sure you follow somebody's plans or something like that have built a bed that can support that kind of weight. Last thing you want to do is make some kind of hazard where you lean on it, the whole thing collapses, your foot's under the bed, something crazy happens. So weight, that's an issue. Expense, it can be expensive depending on the amount of media you pick and the type used. Pea pebbles, expanded shale, lava rock, also called scoria, hydrogen, they're all commonly used, but really you want to look for a local source, okay? Hydrogen is going to be your most expensive. A lot of times if you're in the right area, you can get expanded shale relatively cheap, or lava rock relatively cheap if you're in the right area, or pea pebbles. But go ahead and price things out and do some calls around, because a lot of this has to do with how close you are and how far they have to bring that truck of media. So another con here can be clogging. That media can clog over time if not cared for properly. So unlike a deep water culture system, when we pull a plant out, we remove the entire root system with it. In a media system, you go to pull a plant out and you're going to try to remove as many of the roots as possible, but many of them will stay in there. They've worked in through that aggregate, and they're not going to just readily slip right out when it's time to harvest the plant. Doing that time after time with the added fish waste, with the fixed film nitrification, nitrifying bacteria attaching and living in there, well, that creates solid matter, and that solid matter is going to build up over time. What that can do is, it creates uncontrolled and unwanted anaerobic zones that affect the plant roots. Okay, so it causes channeling in that table. When it floods, the water goes up, it drains, it's going to go the path of least resistance. Okay, so all your solids are mucking up the outer areas. The water is going to flow through the one areas that are not mucked up. And what that allows is it doesn't clean any of that sludge out. It just allows it to build up a little further and to break down and again cause these uncontrolled anaerobic zones. We don't want that. Anything we do, we want to have control over it so that we know what we're doing and we can expect the outcome beforehand. So make sure to remove as many excess roots as possible when we're harvesting plants. That's big. We just talked about that, but it's big. And I would, if you're doing this type of system, I would take the extra time to really get down in there and remove as many as possible. And don't look at it like, oh, the worms will take care of it. Inspect the media between crops to ensure there's not massive buildup of waste in the bottom of the bed. Okay, so dig down there, move stuff around, check it out. You're not going to dig the entire bed up, so you're not going to have some bacterial crash, and hopefully you're not counting on this as your filter anyways. But this will allow you to know what's going on. Easiest way, get in there and look. Don't guess about it for a year or two and then have a crash happen and say, oh, I knew that was coming. Get in there, dig down, take a look for yourself. Okay, power outages can quickly lead to crop loss. So if you're in a shady, northern, cool climate, something like that, not going to happen quite as fast as it will down here in Florida. But here within just a few hours, 1 to 2 hours in the middle of a day like today where it's 98 degrees outside, and you're going to have crop loss. You're going to have droopy plants. The minute your plants droop, you might be able to bring them back, but you're already affecting that plant's potential. You're setting it back and you've fried some of those roots. It's going to take some time to repair that, okay? Don't want to do that. So this is, a con. We're not going to get that in a deep water culture raft system. Power goes out, guess what? The roots are hanging out in that water indefinitely until the water dries up or you fix the problem. The media, again, will hold moisture for a certain period of time, but it really depends on local humidity, climate, but not forever. So keep that in mind. You have to have someone around, or you have to have some good backup equipment and alerts if you're going to run this type of system, especially on a commercial level. Make sure to have backup generator or some other means to water the plants during an emergency situation. Water pump goes out, guess what? You better have an extra pump on hand to get it going. If, again, power goes out, you need a generator to run the pump to water the plants. So these are things you need to look at as fail-safe measures in case you have a worst-case situation. Again, why I would love the deep water culture system. We have a really low risk compared to this system, as you can already see with the points I've mentioned here. Varieties that work best. Well, leafy greens and herbs, okay, those work great. These do great, but can often be done in shallow, elevated tables for ease of harvesting. So like I showed you, those 4-inch tables, that's a very common hydroponic table that they sell off the shelf. It's made out of a food-grade plastic. You can grow just fine in those, 4 inches deep. If you wanted something ready to go, you could buy those, build stands or buy stands for them, and get your aquaponics system going. Vining crops do better with a deeper table, and again, 8 to 12 inches of gravel. These tables should be as close to the ground as possible, and trellises or other supports should be provided so that the plants can be trained to them at an early age. That's really important, and we'll talk about that more with tomatoes. But you have no idea how many people have the potential to grow great vining crops, but because they don't take the early steps to get these plants off in the right direction, they will never produce what they have the potential to produce. And we're going to talk about that a little more, but plants that are meant to be trellised, trellis them. If they're meant to be put on a vined on a piece of twine, put them on the piece of twine. Have that ready to go when you're ready to put the plants in there. Don't forget about it, put it off, let the tomato plants lay down. Oh, I've got to do that, then you get to it. No, you're just shooting yourself in the foot. But again, we'll cover that later on. Long-term crops, so fruiting trees, vining crops, any other large plants, I cannot imagine a plant that we cannot grow in a flood and drain gravel system, okay? I'll just put it that way. anything you can think of. If we match the temperature, we can match the nutrients, it's gonna mimic nature there, so we can do it. You just have to have a big enough gravel container. Don't give me any of this sequoia tree nonsense, because we could we could do it. We just need a humongous flood and drain table. Again, plants should be planted at an appropriate size container for the root system that the plant will eventually have when mature. Think about maturity. Think about tomato plants at a year old, not at 6 weeks old. Think about these things and plan your media bed depending on that size. Because again, you can still grow great plants in flood and drain beds, just not my preference, because we can do it better and easier using a raft system. Root crops. Many root crops can be grown in a media-filled flood and drain system. Just make sure that your bed is at least 2 inches deeper than the root you're trying to grow. Okay, that's something that I've kind of come up with. I don't know if there's a general rule for that, but that's my rule and it's worked good. I've done 22-inch Dagon radishes in 24-inch containers. I've done a lot of stuff, but as soon as that root, the tap root, hits the bottom of your container, it's going to go sideways and it's going to distort the root. And if you're going to eat it, well, you can probably skin around that. If you're going to sell it, what do people want? They want uniformity. So they're not going to want a big crooked root. They want something long, pretty, uniform. Large rough media leads to undesirable root shapes. So I've grown a lot of turmeric, a lot of ginger, galanga, a lot of different tuber type root crops, rhizome crops, things like that. But if you grow it in something like rough lava rock, guess what it's going to come out looking like? It's going to form around that rough lava rock, and it's going to look like not good, not sellable, not high quality. Even though the nutritional quality will be there, it's not going to be what you want. So go with something small, smooth media. That's what's preferred. So I like small pea gravel that's smooth. That works real good. I like the clay pebbles, the hydroxin, but that's expensive. I like for an ebb and flow table, I would like perlite. I think that works really, really good for root crops. But again, you have to not flood it all the way to the top, because perlite will float if you flood it too much. Basically just flood it about a quarter of the container and then bring it down, and it will wick up the rest of the way. So we use perlite, but you have to cover the top with a piece of film so that you don't get a huge layer of algae growing on the top. Again, last thing to mention, root crops are not a high dollar crop unless you have a really specialty market for one. So I would not look at this as your bread and butter if you're trying to form a business. And that's it for this session. Again, if you have any questions at all, please email me, ryan@collegeofaquaponics.com, and I will be sure to cover those questions in our weekly question and answer session and make sure you get all the information that you need. Thank you very much.